The Sun goes through a cycle about every 11 years. It jumps from low activity, or solar minimum, to high activity, or solar maximum. Then it jumps back. We noticed this way back in the 18th century, and we're currently on the 25th cycle. It's all because of the Sun's magnetic field. During solar minimum, the magnetic field is strong and organized, but over time it weakens. Suddenly, solar activity jumps up. This creates solar winds, the Sun spewing jets of particles on the planets, including our Earth. In 1999, the solar wind nearly disappeared for 3 days. It will probably repeat again now. This time around, scientists believe it might hit us sooner and harder than expected. The Sun becomes quite lively, emitting fiery plasma, developing large dark spots, and releasing powerful radiation. And unfortunately, the upcoming solar maximum kind of caught us off guard. The storm was predicted for 2025, so scientists aren't very prepared. The number of sunspots observed has been way higher than anticipated. The Sun hit an 8-year sunspot peak in 2022, and then showed more than double the expected sunspots in 2023. It's not just them. Many solar flares have also been on the rise. In March, the Geomagnetic storm lit up the skies with vibrant auroras across 30 U.S. states. It was the strongest storm in over 6 years. Many rare solar events have become more common recently. For example, a gigantic plasma waterfall, a polar vortex swirling around the Sun's North Pole for hours, and a 3-day solar tornado towering over 14 Earths. Because of all that, Earth faces some risks. Solar storms could hit our planet. It can mess with communications, damage power systems, and cause blackouts, and even pose threats to living beings. They can ionize Earth's atmosphere. This would mess with radio signals and GPS systems. Major disasters like earthquakes or tsunamis combined with such blackouts could lead to catastrophic outcomes. Additionally, strong solar storms may generate electrical currents that can damage infrastructure, including power grids and rail lines. Airplane passengers might experience higher radiation levels during solar storms. It's hard to tell what that would mean for their health. However, astronauts on spacecraft such as the International Space Station could face more significant risks. Future space missions will have to take solar cycles into account. We're not the only creatures in danger. These storms can disrupt the migration patterns of animals like gray whales, sea turtles, and birds. All these poor animals rely on Earth's magnetic field to understand what's going on. And as a cherry on top, there's a risk of satellite collisions. Commercial space companies are focused on launching satellites quickly rather than safely. Because of that, they often overlook the impact of space weather. During solar storms, the ionized upper atmosphere increases drag on Earth-orbiting satellites. If something goes wrong, satellites can be forced out of orbit and collide with us. The scariest solar storm that has ever happened to us was the Carrington event. In 1859, Earth experienced the most intense geomagnetic storm ever recorded. The sky lit up with vibrant auroras. They were visible from the North and South Poles to places like Cuba and Japan. The display was so bright in the United States that gold miners woke up thinking it was morning. It was caused by a massive solar flare. The auroras were breathtaking, but the impact was more than visual. It disrupted telegraph systems across Europe and North America. Telegraph pylons threw sparks, operators got electric shocks, and conversations were conducted using the auroral current instead of batteries. Similar storms occurred at least 3 times throughout history, with the same awful consequences. Scientists estimate the cost of such an event today could range from $600 billion to $2.6 trillion in the US alone. Researchers continue to study historical events and ice core data to understand and prepare for the potential impacts of future solar storms. The Sun's behavior is very unpredictable, but this just shows that we need to study it in greater depth. The chance that this new coming storm will be the same as a superstorm like the Carrington event is low. Besides, if we spend this time preparing, it might go unnoticed. Preparation usually involves adjusting satellite trajectories, grounding planes, and identifying vulnerable infrastructure. Meanwhile, we keep exploring Mars. Its atmosphere is different from ours. Our atmosphere has breathable air, mostly consisting of nitrogen, oxygen, and a lot of other gases. Meanwhile, Mars has incredibly high CO2 levels. If on Earth carbon dioxide doesn't even reach 1%, on Mars, it makes up about 90% of its atmosphere. Also, Earth's atmosphere is over 100 times denser than the one on Mars. Even though Mars is about half the size of Earth, its atmosphere is like a feather compared to our air. A long time ago, Mars could have been kind of Earth-like. We know that it definitely had water, and perhaps there were even some plants. If we added water on Mars now, plants could have grown up there. A long time ago, Mars was experiencing some serious volcanism, suggesting it had a thick atmosphere and maybe even a giant ocean. We're not sure what happened to them, but there are some theories. For example, Mars has a magnetic field, but it's very weak, so solar winds could have stripped away its atmosphere. In the end, it became the chilly, dusty red planet we know today. NASA's Perseverance rover celebrated its 1,000th day on the red planet with some amazing discoveries. The rover cruised through an ancient Martian river and lake system. It gathered 23 precious samples along the way. All of these samples will help us to unlock Mars's history and geological mysteries. Extreme events and conditions are horrifying, but great in a way that they help us to learn more about our solar system. Luckily, MAVEN was designed to be sturdy and prepared even for intense solar storms. So now we can find out more about Mars when it's stripped of its protectiveness.
So this huge volcano, everyone thought to be extinct, woke up and spat out a black ash cloud 50 miles high. That's about 9 times as tall as Mount Everest. Located in what is now Indonesia, the powerful Krakatoa had caused huge tsunamis that rocked over ships as far away as South Africa. It also changed the temperatures around the world for several years. The volcanic island of Krakatoa in the Sunda Strait was likely born thanks to another major eruption several centuries ago. It hadn't erupted for at least 200 years before 1883. So the first tremors and blasts in May of that year came as a total shock to people living nearby. Then ships sailing through the busy water passage started reporting clouds of ash above the volcano. It went quiet again for a while, but they could still see ash above it. The eruption culminated at the end of August. It was so powerful that it shattered the island into fragments. Witnesses heard the sound produced by it in Australia, around 3,000 miles away. They describe the noise as the roar of heavy cannons. Some say it was the loudest sound ever heard. During the next 5 days, the pressure wave from the eruption traveled around the globe 3.5 times and was seen on barographs on different continents. Hot avalanches of ash spread down the volcano as far as 25 miles away at crazy speeds. They ruined the surrounding islands and took 36,000 lives. Tens of thousands more drowned in tsunamis that happened after the volcano had collapsed into the caldera. Over 100 coastal villages on Java and Sumatra were completely wiped out. All this made the waking up of Krakatoa one of the most devastating in the entire recorded history. The Earth's crust is like a giant puzzle, made up of massive pieces known as tectonic plates. These plates are constantly sliding against each other over the mantle, which is the molten layer beneath. Indonesia is right in the middle of the so-called subduction zone. Here, the Indo-Australian plate collides with part of the Asian plate as it moves northward. As the oceanic plate dives down, it gets heated up, and you've got the perfect recipe for a volcanic hotspot. Krakatoa had 3 peaks, each serving as an exit door for a massive magma chamber beneath it. During a previous eruption, debris blocked one of these exits, and the pressure built up beneath. When Krakatoa finally blew its top, the blast split the magma chamber wide open. The eruption led to a so-called volcanic winter. Krakatoa had sent 6 cubic miles of rock, ash, and debris into the atmosphere. They created a thick veil that surrounded the Earth. The particles scattered sunlight, and the troposphere below cooled down. The effect stayed strong for several years. The northern hemisphere experienced colder than average temperatures, and in some regions, summer temperatures didn't rise to typical levels. Southern California received a record amount of rainfall in the months following the eruption. The sky became darker in different parts of the world for years afterwards. The sunsets, for many months, turned into a spectacular show of red and orange. One astronomer supposed it was the source of the inspiration for The Scream by Edvard Munch. The painting shows exactly what the sky over Norway looked like after the eruption. It also produced a rare type of halo called Bishop's Ring and a volcanic purple light at night. For several years after Krakatoa had blown up, the moon looked blue and sometimes green. That's because some ash clouds were full of particles large enough to scatter red light, only letting other colors pass. Someone even witnessed lavender sun and night-shining clouds. Krakatoa became the first scientifically well-recorded and studied eruption of a volcano. Between the moments the first clouds of ash were seen by a ship passing by and the disastrous eruption, scientists managed to organize geological expeditions. They studied the volcano and gathered samples of volcanic rocks. It became useful for understanding volcanic activity. Krakatoa was sleeping tight until the 1920s, when some locals noticed a column of steam and debris spewing from the collapsed caldera. Within weeks, the rim of a new cone sprang up above sea level. After a year, it was a small island named Child of Krakatoa. It continues to erupt, but fortunately without serious consequences so far. In April of 1815, Mount Tambora unleashed a massive eruption, wreaking havoc on the Indonesian island of Sumbawa. It destroyed homes and claimed 10,000 lives. Another 80,000 perished because of diseases that spread in the aftermath. The following went in history as the year without a summer. Cold, wet conditions wrapped Europe and North America in an unexpected chill. It became the coldest in at least 250 years. In the summer of that year, the temperatures dropped the most. Crops didn't grow, livestock didn't survive, and famine took over Western Europe and North America. New England had snow and terrible frost in the summer months. Food prices went up. Oats for horses became a luxury. Some people say it even inspired the invention of the bicycle in 1817. Scientists used early data and climate models to see if it was all because of the Tambora eruption. They compared the data to similar years. They showed that precipitation was around the same, but the temperatures were much warmer. When they introduced the volcano into the scenario, they got the exact data for the year without summer. They say that a powerful volcanic eruption like that one increases the likelihood of extreme cold by up to 100 times. The explosion of the Toba supervolcano on the island of Sumatra around 74,000 years ago became the Earth's largest volcanic eruption in 28 million years. Parts of Indonesia, India, and a slice of the Indian Ocean got a cozy blanket made up of 6 inches of volcanic debris. It spat out a volume of rock comparable to almost 3 million Empire State Buildings. The crater it had left behind is still seen from space. All the ash and volcanic gases that sprang into the atmosphere because of the eruption partially blocked the sunlight. A severe volcanic winter began and lasted for 6 to 10 years. Some anthropologists see a connection between the Toba eruption and how limited modern humans are when it comes to genetic variety. Around 74,000 years ago, exactly when the Toba erupted, there was a population nosedive. That's why all modern humans trace their roots back to a tiny group of survivors. The Toba catastrophe theory proposes that most early humans in Europe and Asia didn't make it through the post-eruption climate chaos. Instead, a lucky, genetically limited bunch found their safe haven in Africa. But archaeological and paleoclimate records disagree with this theory. Benjamin Black from Rutgers University and his team set out to crack the code and discovered a hidden paradox. Maybe we were peering through the wrong climate lens. They ran 42 different climate model simulations, varying the magnitude of volcanic emissions, time of year of the eruption, background climate state, and eruption column height to see what climate disruptions the Toba eruption might have caused. There was a significant drop in temperatures in the northern hemisphere in the first year after the event, up to 18 degrees Fahrenheit. The southern hemisphere, where the early humans were settling, didn't go through a rough cooling that could have affected them all. The most significant eruptions that can seriously change the world's climatic patterns come from supervolcanoes like Yellowstone or Mount Toba. Luckily, these erupt very rarely, about every 100,000 years or more. Still, climate scientists study volcanic eruptions to understand and explain short periods of cooling in the history of our planet. Every few decades or so, a volcanic eruption lets out a substantial number of particles and gases. Some of them will block enough sunlight to start a brief global cooling period. Nothing like the real volcanic winter, but still felt across the globe. Now, if you were to check out the Sahara from space right now, instead of a barren wasteland, you'd spot a surprising sight. Dry land sprinkled with some lakes and rivers in Morocco and Algeria, all thanks to some heavy rains in early September 2024. These aren't oases. This is just the Sahara going back to the factory settings. Believe it or not, eons ago, one of the biggest deserts on Earth was actually a lush paradise full of greenery. Let's first see how the Sahara turned into a desert. During the last ice age, Earth was much colder, and big ice sheets covered a lot of the land. At that time, the Sahara Desert was significantly bigger than it is today, and on our planet there were fewer tropical forests. And the cooler temperatures changed how rain was distributed in the tropics. Now, normally, warm air rises in the tropics, which helps create rain. Since it was colder during the Ice Age, this system got, messed up, and less rain fell in some areas. This caused more dry and desert-like conditions in places that are usually wetter. There was also a lot of dust flowing around in the Sahara Desert, which scientists found in old ocean sediments. But about 12,500 years ago, something surprising happened. The dust levels went way down. This meant that the Sahara got a lot wetter, which is a sign that the climate suddenly warmed up for a while before cooling down again. After 12,500 years ago, the Sahara became a much greener place, like a savanna, because a weather pattern called the Intertropical Convergence Zone, a mouthful indeed, moved north during summer. This wet period was at its best around 4,000 years ago, when temperatures were a bit warmer than today. At that time, more rain fell in the Ethiopian highlands, which made the Nile River carry more sediment. However, there was another big change called a Heinrich event, which caused the Intertropical Convergence Zone to move back south. This led to the Sahara and Arabian regions drying out quickly. Because of this, the Nile River had much less flooding between 2700 and 2100 BCE. Long story short, too late for that. The Sahara has gone through wet and dry cycles due to changes in the climate and weather patterns over thousands of years. Up until recently, we've known about the Sahara in its dry era. But in September 2024, an unusual cyclone rolled through. It hit Morocco, Algeria, Tunisia, and Libya, and filled those dry lakes and rivers. The satellite images from NASA of before and after the rains are stunning. It's like the Sahara has had a makeover. Some areas in North Africa received up to 8 inches of rain. For comparison, Seattle gets about 40 inches per year, only 5 times what the Sahara received. I say only for one simple reason. Seattle has a reputation for being quite rainy, while the Sahara does not. The tricky part is those 8 inches. Essentially, the entire yearly quota for this area fell in a matter of moments. So, in a way, it might have felt rainier in the Sahara than in Seattle. The mountains funnel the water into ephemeral lakes in northern Algeria, which recently expanded to over 70 square miles and reached depths of more than 7 feet. That's enough water to sustain it for a year. So what exactly are these ephemeral lakes? Well, they're basins that fill up for a short time each year, but might stay dry for several years if the rain doesn't cooperate. Sometimes water flows into them from a small surrounding area, or it can just be good old-fashioned rain. Now, a big question arises. How come these lakes exist in the first place? Well, generally they form because there's excess water trapped on the surface. But the soil in the Sahara is incredibly dry. Shouldn't it act like a sponge? It must be thirsting for moisture. Well, think about how eagerly your potted plant drinks up water when you return home from a vacation. However, no matter how parched it is, dry soil can only absorb a limited amount of water, which is often quite small. And just like your potted plant, it doesn't necessarily drink it all. You might simply be overwatering. Or, if you check the saucer below, you could find a mini flood. Another significant factor preventing the soil from absorbing water is the lack of vegetation. Under normal conditions, trees, shrubs, and various plants help retain moisture. In the desert, however, it's nearly impossible. There may be a few palm trees, but that's about it. This also explains the formation of those temporary lakes. Precipitation that isn't held by plants accumulates in low-lying valleys and depressions, creating these fleeting bodies of water. These lakes may only last for a limited time, but that doesn't mean they shouldn't have names. For instance, the beautiful lake adorned with swaying palms that you see is called Lake Yasmina, located in the oasis town of Merzoga. In certain areas of the desert, where the dunes rise, it may appear as though you're looking at a mirage, but it's not. The sand dunes are partially covered by water. Remember how I mentioned 8 inches? Well, that's not entirely accurate for some regions. In fact, there are places where the flooding is so extensive that the palms are submerged up to their crowns. Now, the last time we saw a downpour this intensive was 30 to 50 years ago. But this rain is more than welcome. After 6 consecutive years of drought, Morocco really needed it. Lakes that had been dry for decades, like Lake Ariki, are finally getting some much-needed water. A recent analysis revealed that out of the hundreds of storms that have hit the region since 2000, only 6 brought enough rain to start filling up this lake. And of those, only 2 resulted in a lake level higher than what we saw in September 2024. So while this torrential rain seems like a blessing, the big question is, will it last? The answer is yes. When humid air from near the equator meets the hot, dry air from the north, the Sahara Desert tends to get more rain. Scientists say this collision zone is shifting further north as the planet warms, and it warms, so it's likely to keep moving that way over the next couple of decades. So I seem a bit overly optimistic about this, and the truth is, the news isn't entirely positive. The reality is that no one was truly prepared for a flood situation like this. Moreover, remember that this isn't some Southeast Asian country where people are accustomed to dealing with water. This is the bone-dry Sahara. That said, I think you know what I'm getting at. Tragically, at least 18 people lost their lives to the intense rains in southern Morocco. The authorities are gearing up for even more heavy rain in the region. But if that's the case, could it mean the Sahara is facing extinction? And what would that even mean for us? It might sound a bit strange, but our planet actually relies on deserts, and the Sahara is no different. At first glance, it may seem like a barren wasteland, and it's nothing to write home about. But deserts play a crucial role in our ecosystem. They act as major carbon storage sites and are considered net carbon sinks, with the Sahara alone holding an estimated 1 trillion metric tons of carbon. In the fight against climate change, these existing deserts are like a buffer, helping to keep the temperatures within acceptable levels. Yeah, deserts are scorching hot, but they act as the world's air conditioning. Plus, desert sands are an unexpected source of nutrients for lush areas like tropical rainforests. Believe it or not, scientists have found that the sand particles from the Sahara have a hand in nurturing the Amazon rainforest. These particles travel across the Atlantic Ocean, riding the winds all the way to South America, where they enrich the soil in the Amazon basin. Without the Sahara, experts believe the Amazon rainforest could face serious collapse.
The universe is not static. It evolves all the time and grows in all directions. It's expanding, and scientists found this out almost a century ago. and it's not at a stable rate. The more time goes by, the faster the universe expands. As this happens, stars, planets, and galaxies move farther and farther apart, which leaves more space between them. If that's the case, the universe is supposed to become colder as it expands, right? After all, it was a lot denser when the Big Bang happened, and a lot hotter. As it was expanding, space was cooling down, which created conditions for planets, stars, and other space objects to form. Yeah, that's not exactly the case now. Scientists were surprised to hear it too. But our universe is actually getting hotter. They observed the temperature of cosmic gas farther away from our home planet compared to young gases closer to the Earth. Since we measure distance in space by light years, farther areas are like going back to the past, and regions closer to us are like observing the present day. They found out the temperature of a gas in space has gone up more than 10 times in the last 10 billion years. Now, the temperature of the cosmic gas that's spread all across the universe can get to around 4 million degrees Fahrenheit. Wow! As the universe expands, gravitational force does its part and pulls gas and dark matter together. It's doing some pretty hard work there. It creates galaxies and clusters of galaxies out of them. And this process is totally chaotic. It's so messy that more and more gas heats up as all of this is happening. Space was extremely hot when it was just forming 13.7 billion years ago. What if it gets warm like that once again? Scientists are observing the situation. They found out the temperature in space increased by measuring cosmic gases using something called redshift. They generally use this method when they want to see how far away some space objects are. Those that are closer to us have shorter light wavelengths. The farther some object is, the longer its light wavelengths are. And they can now determine the temperature of a certain object from its light. On average, space is a pretty cold place. The glow that's left from the Big Bang is called the CMB, which is short for the cosmic microwave background. It's so powerful and intense, it bathes the entire universe in light. It's the only thing that significantly heats up matter. But there are many smaller mechanisms that help to heat up matter in the universe, and they could go crazy if space warms up, like stars. They emit radiation that affects nearby dust and gas. They radiate throughout the far infrared too. When a star is at its early stage, the radiation coming from it forms protoplanetary structures that look like disks. They primarily form in a single plane, and a bright central star produces spectacularly illuminated gas, and there are blue reflections of this gas. It was like that with our planetary system too. Strong energy and gravitational forces cause collisions, dust, and gas in an uncontrolled vortex that's forming planets. That's why most planets in our solar system orbit in the same direction. That's the direction this giant whirlpool was spinning a long time ago too. Active stars, colliding galaxies, stellar cataclysms, black holes, neutron stars. The universe has so many sources of energy. And when you surround normal matter in space with such an energetic environment, it heats up drastically. When you heat something up, it radiates that energy away in a certain way. In most cases, galaxies have just a couple of areas where stars are forming, at regions where gas is collapsing. A bubble that surrounds that area contains ionized hydrogen. 3/4 of our sun is hydrogen. Thanks to that hydrogen, the sun keeps us warm. In its core, hydrogen transforms into helium and causes atomic fusion. Yep, that's how our sun releases its energy. Radiation heats all that gas to thousands and thousands of degrees. At the same time, it ionizes a large number of atoms and molecules, which basically means it turns them into ions. Atoms are neutral particles, and ions are either negatively or positively charged particles. If the universe heats up, our sun might too. If its temperature hits 30,000 degrees Kelvin, it could become hot enough to ionize all those materials it had previously ejected. And it could create a real planetary nebula. This would be a nebula in the shape of a ring that forms because of an expanding gas that surrounds an aging star. As the temperature goes up all the time, hydrogen ionizes. At a few thousand degrees, this could turn the nebulae in our solar system pink with emission lines. Our sun could come to its end if it reaches the temperature of 50,000 degrees Kelvin. If you could float in space and come closer, you'd see it glow in eerie green tones because of doubly ionized oxygen. Higher energy phenomena make more galaxies collide. This heats gas even more and eventually results in X-ray emissions. What about black holes and radiating neutron stars? When they go crazy, they can shape whole galaxies, and who knows what more. Maybe we'd have more masers too. Those are natural lasers our universe produces. They arise when big populations of molecules receive large amounts of energy. By now, scientists have found the strongest, yet the most distant maser. So powerful, it's more luminous than the light 6,000 suns would produce, and in just one emission line. Maybe then we'd discover even stronger masers. That's in the case that we're even going to be here at all. Because as the universe is getting hotter, cosmic radiation is getting stronger. Not so good for life on Earth. Increased cosmic radiation could harm us. Who knows if life would even be possible on Earth in that case, or if the powerful gravitational force would pull our home planet too, and crash it into another one. But maybe life as we know it wouldn't completely disappear. Or, if that happened, it could possibly somehow find its way once again, maybe in the distant future. There's a possibility our universe could support life at its early stages. Doesn't look like that when you think of the chaos the Big Bang caused, right? But that was only in its mere beginnings. After things had settled down a bit, the dregs of enormous, earliest stars formed rocky planets. In our solar system, those are Earth, Mars, Mercury, and Venus. You can't set your foot on the rest of them since they're gas giants. Back in that time, radiation was quite intense, so rocky planets had an adequate environment to form, since it takes a lot of energy to whirlpool dust and particles and bake a planet in the end. This period of time coincides roughly with that when the first stars formed in our universe. Ancient stars were way bigger than our sun. They lived shorter though. They would have just exploded as supernovas on their end, and they would leave heavy metals across the space around them. Those are the particles rocky planets formed from. Radiation spread around the whole universe back then. It has changed over time. Today, it's almost an absolute zero. 400,000 years after the Big Bang, when hydrogen atoms were forming, CMB was almost as hot as the surface of our sun. And about 15 million years after the Big Bang, its temperature was close to room temperature, which is around 80 degrees Fahrenheit. These things were happening across the universe, so there were many planets that could potentially hold life. If we were one of those ancient worlds, we wouldn't need a star to keep us warm. CMB would be enough to do it. So, it's possible that life in space is way older than we think it is. There could have been ancient worlds with liquid water on their surface. What if there were some primitive forms of organisms, like on our home planet a long time ago? Or even more developed ones? Perhaps we'll find out one day.
Doctor, I can't understand what's going on. I feel dizzy and, how do I say it? I'm tilting. It didn't happen overnight. Like, I didn't wake up and couldn't stand straight. No, one day, I felt that my axis had shifted by 1 inch. Another day, it was 2 inches. And once, you won't believe it, it was 31.5 inches. That's alarming. What if I accidentally turned upside down and all my inhabitants fall off my surface? Ah, dear Earth. We ran some tests and are ready to explain an unfortunate combination of factors that has affected your axis. The last one will perhaps be the most unexpected and upsetting. It all started back in March 2011, when a devastating magnitude 9 earthquake struck off the coast of Japan. It was so powerful that not only did it shift Earth's axis, but it also shortened the length of the day. This earthquake displaced our planet's axis by approximately 6.5 inches and may have moved Japan's main island by about 8 feet. Like other similarly massive earthquakes, it also altered Earth's rotation speed. To make it easier, let's compare it to a spinning ice skater. When a skater pulls their arms close to their body, they spin faster by concentrating their mass near the axis of rotation. Something similar happens during the most powerful earthquakes. They shift Earth's mass closer to its rotational axis, causing it to spin faster and shortening the day length. The calculations showed that the Japanese earthquake sped up Earth's rotation by about 1.8 microseconds, which is about 1.8 millionths of a second. Not a big deal, but at the end of the day, every nanosecond counts. For comparison, the infamous Indonesian earthquake shortened the length of a day by 2.68 microseconds. It struck on December 26, 2004, at 0:58 UTC. The epicenter lay off the western coast of northern Sumatra, Indonesia. This powerful undersea earthquake triggered devastating tsunamis that swept across the Indian Ocean, causing widespread destruction and immense loss of life in countries like Indonesia, Sri Lanka, India, and Thailand. Even coastal areas as far as East Africa had severe damage. The Earth's magnitude, initially recorded at 9.0 on the Richter scale, was later adjusted to between 9.1 and 9.3, making it the most powerful earthquake ever recorded in Asia. The faulting, that's when Earth's crust completely breaks and its parts slide past each other, lasted between 500 and 600 seconds, and it was the longest duration ever observed. The immense force of the quake caused the entire planet to vibrate by at least half an inch and triggered other earthquakes as far away as Alaska. All that immense energy the earthquake released caused subtle but quite measurable changes to Earth. The shift in mass slightly changed the planet's rotation, shortening the day. It also caused a small wobble in Earth's axis from 1 to 2.4 inches toward 145° east longitude. So, when it comes to changes in Earth's rotation speed and axis, it's all about the redistribution of mass. This can happen naturally through disasters, but human activities can also trigger it. Take the Three Gorges Dam, for instance. This massive structure across the Yangtze River in China's Hubei province may seem to be an engineering triumph, but it's pretty ambiguous. Finished in 2012 after nearly 20 years, this massive dam is 7,660 feet long and 607 feet high. And yes, it is so big that it can affect the way our planet spins. Its reservoir is capable of holding 9.5 cubic miles of water, has enough mass to slightly alter the Earth's rotational inertia, slightly slowing the planet's rotation. According to NASA, the Three Gorges Dam reservoir could shift Earth's pole position by almost 1 inch and increase the length of a day by 0.06 microseconds. Dams aren't the only worry. If polar ice melts, water rushes into the oceans, hiking up sea levels, especially near the equator. This mass shift slows Earth's spin way more than dams do. You won't feel it day to day, but it can affect ultra-precise equipment, such as atomic clocks. To fix this, scientists suggested a negative leap second, making a minute 59 seconds, to balance Earth's spin changes. Okay, so you're thinking you've got nothing to do with all those tilts. You don't build dams, right? Bad news. If you take regular showers, you're part of it too. Every time you turn on the tap, you're affecting Earth's tilt just a tiny bit. Thing is, our planet is always shifting and adapting, so even small actions like using water can influence its orientation. Over the past 2 decades, groundwater pumping has caused the Earth's tilt to shift by 31.5 inches. This water redistribution is equal to about 0.24 inches of sea level rise. It turns out that among climate-related causes, groundwater redistribution has the largest impact on the drift of Earth's rotational pull. But what is groundwater? It's the water stored beneath the Earth's surface, filling the spaces in soil, sand, and rock. It comes from rain and other precipitation that seeps into the ground, collecting in underground reservoirs, aquifers. Unlike rivers and lakes, groundwater stays below the surface, acting like a natural water reserve. Thanks to it, we have a steady supply even during dry periods. Many people, especially in rural areas, rely on groundwater as their main source of drinking water. Farmers use it to irrigate crops, while industries depend on it for manufacturing and cooling systems. It sounds pretty harmless, doesn't it? How can something so useful cause our planet to shift? Well, a study covering data from 1993 to 2010 revealed that we've pumped about 2,150 gigatons of groundwater in that time. And this large-scale water removal has shifted the Earth's tilt and rotation. After we use groundwater, much of it eventually flows into the oceans, contributing to rising sea levels. In areas like Western North America and Northwestern India, people use a lot of groundwater, and it may have a connection to these shifts. Yikes, let's face it. All these findings are rather disturbing. But understanding the impact of groundwater use is already a huge step in the right direction. Hey, I'm not done yet. This tilting issue isn't just about stuff happening on Earth. We also need to look at space. We've talked a lot about water, right? Well, you know that the moon has a big role in that. Its gravity is super important for forming tides and all that. So one more thing that affects our planet a lot is the gradual movement of the moon away from Earth. These two bodies interact gravitationally, which makes Earth's rotation slow over time, even though significant events like earthquakes occasionally speed it up temporarily. How did we figure it out? Glad you asked. Once, someone paid attention to ancient corals. After analyzing them, scientists realized that Earth had once rotated much faster. The thing is, corals grow by laying down thin layers of calcium carbonate. They do it daily, and variations reflect seasonal changes. By counting these layers, scientists have calculated the number of days in a year millions of years ago. They found that Earth had about 420 days per year 444 to 419 million years ago. But over time, the moon's influence had caused Earth's rotation to slow. And now we only have 365 days in a year. I feel robbed, At the moment, the moon is moving 1.5 inches away from Earth each year. That's about the same speed at which your fingernails grow. Astronomers have figured it out with the help of special mirrors placed on the moon during the Apollo missions. For over 50 years, researchers have been sending laser beams to these mirrors and measuring the time it took for the light to bounce back. In any case, dear Earth, at the moment, your condition isn't critical. As for your inhabitants, they won't fall off your surface. All thanks to your gravity, pulling them toward your center. Just don't switch it off, and everything's gonna be fine.
Earth, 4.5 billion years ago. The pale blue dot we know today was anything but suitable for life. Glowing red and fiery hot, volcanoes erupt over the entire molten surface. The average temperature is well over 3,000 degrees Fahrenheit, much hotter than even lava. The planet, just born, was constantly under a barrage of meteor impacts. In fact, a Mars-sized object would soon crash into young Earth and form the moon. You couldn't live there, and breathing is certainly out of the question. Those continuous volcanic eruptions released toxic gases into the sky. Our Earth had almost no atmosphere. But then, life found a way. Chemical reactions from those same volcanic eruptions would help create an atmosphere. The planet cools and hardens, water appears, oceans form. They fill with microorganisms that release a rush of oxygen into the air. The atmosphere becomes breathable. Complex life appears and evolves. And the rest, as they say, is history. Now imagine that atmosphere, the very thing we breathe, our warm blanket, the planet's protective bubble, was gone in the blink of an eye. But not for long, just 5 quick seconds. Surely we can handle it, right? Time slows down and 1 second in. Everything immediately becomes silent. Just imagine you're screaming or saying something, but no one can hear your voice, just like in outer space. There's no atmosphere for sound waves to travel through. You can now only feel vibrations in the ground. Right now, life on Earth is like being in a vacuum. The planet has also lost the shield that protects us from solar energy. The sun's rays are too strong and toxic to handle. These rays are usually filtered when they pass through the atmosphere. The heat gets distributed throughout the planet evenly. But at this moment, the most unlucky are those sunbathing on the beach. But most people don't feel it yet. In the first second, they can only feel the temperature increasing. Many plants aren't as lucky as humans. They're less protected and get scorched in this brief second. But the worst thing is that oxygen stops being created in nature. Grass, trees, plants, flowers, all of them absorb carbon dioxide in the atmosphere. Using the sun's energy, they convert this gas into oxygen. You probably remember learning about this in school. It's photosynthesis. But most of our precious oxygen actually comes from the ocean. Well, the seaweed and microorganisms in it. The ocean releases a huge amount of oxygen that rises into the sky. Then, the atmosphere distributes it throughout the planet. Now, without that natural distributor, we can't get that precious gas our bodies need. Humans won't feel it in the first second, but for many other living beings, this moment can be critical. 2 seconds with no atmosphere. People outside get sunburned. Beachgoers can't rely on their umbrella for protection. It'll soon be scorched by the hot rays. In places where the weather is bad now, all the clouds dissipate. Because of the high temperature, water evaporates into space. Where it's night now, a new ice age begins. The heat has stopped spreading evenly all over the planet. The rain turns to ice. Heavy hail starts. Most living nocturnal animals are freezing. People out on the streets of big cities at night don't freeze in the first couple seconds. Cities create their own heat, and it saves residents. For now. The climate that was once so varied, warm, dry, rainy, wet, windy, it's reduced to only 2 options, extremely hot and extremely cold. Water begins to boil in lakes, rivers, seas, and oceans, but not because of the hot temperature, but a pressure drop. The air disappears. There's no longer a boundary between space and the planet. The sun's shining, but the sky's losing its color. Blue is replaced by black. The Earth becomes like the moon. The planet is bombarded by solar storms. There are flashes of energy that shoot out in all directions from the sun. Without an atmosphere to protect us, the storms disable all electronics, lights go out, the internet stops working, and cell towers are broken. 3 seconds in. Nature has taken a real hit because of the extreme temperatures, but the worst is yet to come. The atmosphere protects us not only from the sun's energy, but also from space debris. Thousands of satellites have been disabled and are now falling to Earth. They start to rain down on this planet. And with no warning, usually meteors and anything else falling toward Earth get entirely burnt up in the atmosphere before they even reach the planet's surface. Our world's gravity pulls them in at breakneck speeds. The air resistance is too much, and friction skyrockets. A flame ignites, and you can see falling stars in the sky. Not anymore. The nightmarish rain will take us by surprise. If the atmosphere doesn't come back soon, small coin-sized meteorites will pierce through houses, cars, fields, roads, everything. Larger meteorites, the size of a soccer ball, could create a powerful blast. Places everywhere will spend billions of dollars on repairs. It's impossible to be in the sunny parts of the planet. The temperature is too high. The luckiest ones, whether human or animal, are underground. People in the subway don't feel the heat. They're also protected from the sun's toxic energy. Everyone has trouble breathing. Not enough air to fill your lungs. The world is starting to panic. 4 seconds in. Many are starting to feel dizzy. Some lose consciousness. The cells of your body stop being saturated with oxygen. Your body responds in a panic and starts pumping out adrenaline. Heart rate increases, pupils dilate. The brain tries to find a solution, but fails. People start to get even more nervous. They'll remember this short-term shock for a lifetime. 5 seconds with no atmosphere. There's much less oxygen to breathe. Algae and plants are burning or freezing. Small rivers and lakes have almost dried up completely. They're down to a quarter of their size. Usually, the force of gravity pulls birds down, but they flap their wings, push off the air resistance, and rise up. Now, the airflow is gone, and only gravity remains. Birds are falling from the sky, flapping their wings helplessly. They're joined by airplanes. Just when it looks like it'll be a true horror scene, snap! And the atmosphere returns. The planet fills with oxygen and heat. Birds manage to rise in the sky again. Pilots get control of the yoke and save millions. The black sky returns to blue. The sun's rays don't burn so much. The heat gets distributed all around. The temperature rises in cold places. People can take a deep breath. Bodies of water stop boiling. Surviving plants resume the process of photosynthesis. You hear your own voice and other sounds again. Life returns to normal. Oh, well, don't forget the meteorites. Hundreds of cosmic rocks and space debris start to burn up, but it's too late. They're too close to the surface and don't burn up entirely. Several meteorites fall into the sea and form tsunamis. The ones that crash into the ground wreak havoc. Luckily, the rain is over as fast as it began. No one can use their phone yet because the connection hasn't been restored after the solar storm. The only question on everyone's mind is, what just happened? The atmosphere's vanishing for a mere 5 seconds showed how much our planet truly needs it. Humanity won't stand a chance if the atmosphere disappears forever. Fortunately, we have technologies that allow us to monitor the state of our planetary shield. If it disappears, we must be prepared for it. People will build large domes that won't allow solar storms to pass through. Inside, we'll create an artificial atmosphere that maintains a normal temperature and pressure. It filters the sun's rays so plants can release oxygen. Outside the domes, Earth will look more like Mars. You'll only be able to go out there in a spacesuit. Anybody who couldn't get a place under the domes will go underground. They'll live deep enough to be protected from the sun. It'll be impossible for them to use our star for energy, so they'll take it from the Earth's core. And no need to worry about a reliable source of water. There are rivers and lakes underground. But who knows? Perhaps humanity will have already found a new habitable planet. So if the atmosphere ever suddenly disappeared, we'd be watching from a distance.
So even if our sun was completely made of bananas, it would still be insanely hot, just like it is now. But it would have more appeal. The sun is boiling hot because of its large weight. Its billions and billions of tons create powerful gravity and put enormous pressure on the star's core. This pressure raises the temperature, similar to a bicycle pump that gets warm when you pump the tires. Great pressure leads to high temperatures. Imagine having 1 billion tons of bananas hanging in space, instead of hydrogen, the element our sun is mostly made of. There would be just as much pressure, which means the temperature would be just as high. The main difference here is, as well as the reason we don't have a banana sun, is that without hydrogen, the sun wouldn't be able to fuel itself. A banana sun would cool down pretty fast, and it wouldn't be able to burn for billions of years. Sandcastles hold together because of the surface tension between water molecules and molecules of sand. Water creates tiny grain-to-grain bridges so that damp sand can stick together and your castle can stand on its own. Surface tension is also the reason you can see certain insects walk on the surface of a pond. It also acts like rubber bands between tiny grains of sand. When you add water to damp sand, you actually fill spaces between those grains. Now, the faster your body moves, the heavier it gets. At first, this sounds as if you gain extra weight if you run very fast. But don't worry, it's only a small amount, and it happens momentarily, and only if you move almost as fast as the speed of light. Raise your hand. Anybody? Okay. The speed of light is the limit of the universe. If you move so fast it's close to the speed of light, and then you give it an extra push, you still won't be able to run faster. But you've already given that extra energy, and it has to end up somewhere. So it goes into mass, because according to the theory of relativity, energy can be converted into mass. Now, there are probably over 100 billion galaxies in the cosmos. Each of them has up to 1 trillion stars in it. Our sun seems big to us, but in terms of the universe, it's a tiny, feeble star. We can say there's a lot of visible matter out there in space, but it's still less than 5% of its total mass. The rest is dark matter and dark energy. Dark matter makes up the majority of the mass of galaxy clusters and galaxies. There are no instruments that can help us see it, but astronomers believe it's there because of strong gravitational effects that impact the way galaxies are organized. Dark matter could also be the reason scientists sometimes see interesting optical illusions in the deep universe. For instance, images of galaxies with unusual rings or arcs of light. Maybe it's the light from faraway galaxies that reaches us. But at the same time, there could be large, invisible clouds of dark matter that distort it. No one knows for sure what dark matter is, and dark energy is even harder to explain. But scientists think this could be the very force that makes the universe expand. The same temperature doesn't always feel the same in different surroundings. When you check the temperature, the number you see may be objective, but how you sense it is definitely not. In most of the United States, the temperature of almost 90 degrees Fahrenheit is hot. But in the South, it might be a day of sweet relief, a chance to go enjoy a family picnic. At the same time, headlines can be warning about extreme temperatures of 88 degrees Fahrenheit across the UK. How you feel when you open your door and go outside is both a matter of culture and science. Of course, where you live influences how comfortable you're going to feel at certain temperatures. That's the surroundings your body is adjusted to. Plus, there's this additional info on your weather map, sometimes called real feel. In the United States, for example, people can check the heat index. It measures the difference between the real temperature and the perceived one. The heat index analyzes humidity and air temperature. It tells you that 88 degrees Fahrenheit with 40% humidity actually feels like 88 degrees. But the same temperature with 90% humidity will feel like it's 113 degrees, which won't make you feel as comfortable as in the first case. Now, you must admit it feels somewhat wrong when you drink tea out of a plastic cup. You may think it's because the hot liquid somehow dissolves the plastic, but not really. The taste you perceive is not just a quirk of your taste buds. It's the result of the common work of your different senses. Crisps will feel crunchier when you can hear the sounds of higher frequencies you produce when you crunch them. Studies have also shown that cheesecake tastes better and sweeter when it's served on a white plate compared to when it's served on a black one. We're conditioned to expect tea to be served in a ceramic cup. When we drink it from a plastic cup, we subconsciously expect vending machine tea that's not going to taste that good. In certain conditions, some things can travel faster than light, since light doesn't always hit its full speed. To be more precise, the speed of light in a vacuum doesn't change. It's nearly 186,000 miles per second. But it's not like light always travels through a vacuum. For instance, in water, photons, which are tiny particles of light, travel at only 3/4 of the speed of light. In nuclear reactors, certain particles can reach very high speeds. If they're going through an insulating medium that slows the light down, they can move faster than the light that surrounds them. This creates a blue glow. That's why underwater cores of nuclear reactors can glow in the dark. How come a candle releases smoke only after you extinguish it? Smoke is actually a bunch of unburnt particles of carbon that get released when candle wax breaks down. When the candle is burning, most of the carbon turns into carbon dioxide, but some of it gets away. You can test it yourself. Put a plate above a candle flame and hold it there. The carbon will accumulate as a dark smear. When you extinguish the flame, the glowing wick still has enough heat to break up the molecules of wax. but it's not enough to burn all the carbon. So you see a trail of smoke until it all cools down. When you place plastic items in the dishwasher, you can see water droplets stay on them after the washing. Dishwashers work in this way. They spray jets of detergent and water at temperatures that are higher than you'd use when doing the dishes yourself. When the washing cycle is finished, the water evaporates and the crockery gets dry. But plastic things cool down faster because this material has a lower density, and water doesn't have enough time to evaporate. The human stomach is more capable than you might think. It can even damage razor blades within 24 hours. We rank acids on a scale from 0 to 14. The stronger the acid is, the lower its pH level goes. Our stomach has a very strong pH, which is why its acid is mostly ranked from 1.0 to 2.0, so it can erode razors relatively fast. Just trust us on this one. If you're standing on top of the building, time goes faster than when you're down there at the bottom. It's something called gravitational time dilation. It's explained in Einstein's theory of relativity. The theory says that the farther something is from our planet's surface, the faster time goes. Just as when you're waiting in a long checkout line in the store, time slows down. Now, objects with larger masses produce a stronger gravitational field. That field is actually a curvature of time and space. The stronger a gravitational force, the more space-time distorts. This way, time itself flows more slowly. Of course, when you're in a strong gravitational field, you feel that your time passes normally. You can see the difference only compared to a weaker gravity, where time runs a bit more slowly. This is why it really helps in the store to have an express checkout line. That tends to go faster. Just saying. In September 1859, scientists observed the first confirmed powerful solar flare. The sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 93 million miles away, so it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington effect. The good news is that this happened in the middle of the 19th century and didn't cause serious problems for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma or charged gas. At one time, the sun can throw billions of tons of this material into space. Then, all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered along the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable, GPS is buggy, data is poorly transmitted. Also, solar-charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies would go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we'll have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If the satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of magnetic field during long flights to the south. So, not only people, but also animals may experience serious problems. Solar storms heat the upper layers of the Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude, and one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure, like it happens when the weather changes. So people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the Sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at 1,000,000 miles per hour, and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the Sun increases every year, then we'll have to come up with new innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field, because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the Sun are similar to this tousled hair. When the Sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the Sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the Sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, X-rays, radiation, and visible and ultraviolet light. During flares, the Sun releases an enormous amount of this destructive energy, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares, because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much, but they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the way radiation does, but only if you're in space or flying a plane in the upper atmosphere. Soaring temperatures of more than 11,000 degrees Fahrenheit, solid rocks of blazing superhot fire, immense pressures 3.5 million times stronger than on the surface of the Earth. These are just some of the things cooking 1,800 miles beneath your feet as you're watching this video. How? The Sun is burning with a temperature similar to our planet's core, but it's 93 million miles away. So why isn't Earth melting away from its own core? Our little blue planet is made of many layers stacked one upon another. The inner core, the outer one, the mantle, and the crust. The deeper you go, the hotter and more pressurized it gets. Plate tectonics are layers of the mantle and crust piggyback riding, forever moving and just having a good time. Scientists discovered there are 9 plates in total in different parts of the world. When these plates move and grind on each other, earthquakes occur. Energy is released as a result, and we feel it on the surface. Think of it as trying to shut a car door after stuffing it to the brim. When you realize there's something in the way, remove it, and boom, everything topples. Billions of years ago, our lands were all interlocked in what was called Pangea. But slowly, and I mean slowly, over the years, the continents drifted apart into what we have right now. The Earth was also cooler on the inside, but it slowly started generating more heat in the core. Earthquakes are measured with intensity and magnitude. We see how far the effects of an earthquake reach through magnitude, and the intensity is the measure of its power. Over at the mantle, the cooler rocks begin sinking and hot material from the core rises up. When this happens, the plates begin moving, and as a result, they create mountains, hills, and bodies of water we have today. None of these things happen overnight. It takes millions of years to actually see something. All the way in the layers of the Earth, there are different sources of heat, mainly from when the planet was initially formed. Friction heating occurs when materials begin sinking down to the center of the Earth. Since the Earth is surrounded by a solid mantle, the crust floating on top of it acts as a barrier to protect us from the Earth's insides. But the secret for its success is the difference between heat and temperature. Simply put, heat is just energy, and temperature is its density. If the Sun was 1,800 miles away from the surface of the Earth and boiling at the same temperature as our core, we would melt like ice cream on a hot sunny day. A shock from a small short circuit when plugging out your phone charger from the socket won't be too harmful, even though a spark can have temperatures of around 2,700 degrees. But if you dipped your body in a boiling bath of hot water at around 200 degrees, let's just say it's not worth it. Just because the temperature of the Sun's surface is roughly the same as the Earth's core, doesn't mean the heat distribution is the same. The Earth's core is teeming with iron throughout the layers, but on the surface, the iron atoms are arranged into cube shapes. That's when iron is in normal room temperature and regular pressure. But put in extreme conditions, the atomic shape changes into hexagons. For a long time, scientists thought that the iron in the core was hexagon-shaped, but they found out it retained its cubic formation 1,800 miles underground. Since the core has so much pressure, the atoms simply don't have a place to move to change their shape. If you were standing in a subway train that was packed full, you wouldn't even have space to lift your arm. But everyone inside is able to switch positions while keeping the original shape. That's why the structure of the Earth's core is solid and not liquid. The atoms are so tightly packed that they can't even transition into a liquid state. But in a world where the Earth's core liquefied, we'd witness the worst consequences, starting with major and mass volcanic eruptions, earthquakes, and tidal waves. Every major hotspot would be in danger, and the ring of fire would be a non-stop fountain of lava spewing out. Cool material from the upper layers sinks down to the core and vice versa. With a liquid and incredibly unstable core, this process would be much faster. every major city and town by the coast would be washed away by tidal waves, and all the volcanoes erupting will blacken the sky with ash and smoke. This would temporarily block the sunlight from entering our atmosphere and eventually force anything flying in the air to remain on the ground. The lands we currently live on would feel like ice breaking away from a glacier and floating off. Many dormant volcanoes would wake up from their slumber and spew out their morning lava all over the place. The ground formation and structure would change permanently. Magma from the bottom of the ocean trenches would find its way up to the surface and change the currents in the oceans. The Arctic Ocean and Antarctica would melt away and add to the rise of water levels all around the northern and southern hemispheres, and eventually the world. Wildlife on land wouldn't be able to flourish, and all the greenery would disappear. Marine life would have to find a way to escape the changes in the ocean temperature. The world economy would crash as an international emergency would be declared to try and figure out a way to stop this. But humanity would barely make it alive and would have to strive to continue existing. Well, of course, something like this will never happen. But if the Earth's core cooled down, then we wouldn't have massive volcanic eruptions, no devastating earthquakes nor tidal waves. In fact, none of these things would happen since they require energy to function. The continents would stop moving and changing. Sounds cool, right? No. This means that the magnetic field protecting our planet would disappear, which would make us extremely vulnerable to cosmic radiation, as well as asteroids and meteorites. The sun's rays will feel even more intense than usual, which will make it extremely unsafe for anyone to go outside. The heat produced in the core is responsible for recycling the carbon that goes back to the surface. Now, recycling would stop altogether. Carbon is an essential part of carbon dioxide that plants need to survive. So all the trees and plants on the surface and in the water would stop growing and wouldn't be able to produce oxygen for the rest of the world. With cosmic radiation and lack of oxygen, humans would have to live in bunkers with artificial ventilation systems. The Earth's surface would become a no-go zone and start to resemble Mars. With nothing to power the Earth from the inside, it'd begin to dry up and crumble internally. Much of the Earth's surface is made out of oxygen, so without it, we would eventually see something like major sinkholes around the world. Sinkholes that can take down cities like New York and Paris, along with landslides in many cities and unstable landscapes all over the place. Every single city's infrastructure would eventually collapse and make the ground unwalkable. So even if you did live in an underground bunker, chances are the foundation wouldn't last and you'd be exposed to the cosmic radiation. But all of this can vanish in the blink of an eye if an asteroid comes falling down. Whether it's tiny or colossal, we would be seeing more of those than actual rain. Without a magnetic field, the Earth can't block any foreign object that flies through our atmosphere. If an asteroid the size of Rhode Island came falling down, the damage would be much more than with the Earth's core hot and running. With the ground as fragile as potato chips, the ripple effect would be much wider and cause more indirect destruction around us. The Earth would eventually collapse in on itself and break into pieces until it's lost its own gravitational energy. It'd end up being a bunch of rocks and pebbles floating around in the emptiness of space. But nothing like that will happen either. We're living fine with our solid hot Earth core. As long as it's doing okay, then we can keep on doing our thing.
Hey, want to take a wild trip back in time to the Jurassic or Cambrian era? Trust me, it's gonna be a wild ride, but surviving in those ancient environments would require some serious skills. At the start of the Cambrian era, the air would be as thin as at the base camp of Mount Everest, but the climate was actually pretty chill and consistent back then. However, there was one teeny tiny problem: no land plants or animals to feast on. So forget about firing up the grill for a juicy steak. Instead, you'd have to come up with creative ways to catch trilobites and other funky-looking shellfish. Good luck finding a spear without any wood or a fishing net without any plant fibers. And get ready to eat them raw, unless you can figure out how to extract oil from these creatures or burn dry seaweed. But wait, if you're looking for a more comfortable existence, you gotta travel to 100 million years ago, to the Silurian period. Here, things start to get a bit easier. The air is still thin, but there's a bit more oxygen to go around. Plus, the climate is warmer and cozier. Simple land plants have finally made their debut. Not only that, but the first bony fish also show up on the scene, so you might actually find something more palatable to munch on. Just watch out for those prehistoric millipedes and spider-like creatures that share the land with you. They might not be the best dinner companions. Yeah, it all sounds fun and feasible, but let's talk a bit more about this crazy idea of instant transportation. If you magically appeared in a different time, the first thing you'd have to worry about is the amount of oxygen in the air. Now, looking at that fancy graph up there, it's pretty clear that oxygen levels used to be super low before about 0.85 billion years ago. Like, we're talking just a few % of the atmosphere. And there wasn't even any O2 in the air until this event called the Great Oxygenation happened about 2.3 billion years ago. So if you ended up back then, surviving would totally depend on how fit you are. If the oxygen concentration was less than 10%, you'd probably pass out, but not pass away. If it was just above 10%, you might be able to function, but you wouldn't exactly be living your best life. Based on oxygen alone, it seems like you could survive if you showed up around 0.75 billion years ago, give or take a few million years. Now let's talk about the cool stuff on land. The first land plants didn't show up until around 450 million years ago during the Ordovician period. Before that, there were some large algae hanging around, mostly in the range of 500 to 600 million years ago. But there wasn't a whole lot going on until those land plants came along. Other forms of life didn't start showing up on land until closer to 300 to 400 million years ago. But there was this critter, a myriapod, that lived around 428 million years ago, and it was one of the earliest land dwellers. I mean, if you lived back then, you'd have to come up with fancy recipes featuring myriapods. Not exactly mouth-watering. Don't worry if you find yourself back in time before all that land action. Around 500 to 600 million years ago, the oceans were teeming with life. There were these creatures called the Ediacaran fauna, and they were some of the first well-preserved organisms. Some of them probably hung out in the shallow areas near the shore, so you might be able to get your hands on them for a meal. But remember, there weren't any land plants yet, so you'd probably have to eat them raw and with no potatoes on the side. You'd have a sort of prehistoric sashimi on your plate. Now, around 500 million years ago, things started to get really interesting in the oceans after something called the Cambrian explosion. If you ended up in the Cambrian period, you'd have all sorts of weird animals to catch in the coastal zones. Check out the fossils from the Burgess Shale for some wild ideas. Look at these brachiopods, arthropods, and even worm-like critters. But again, no woody land plants at this point, so your meals would mostly consist of raw arthropods and algae. Alrighty, let's dive into the nitty-gritty of ice ages. It's when the Earth gets super chilly for a ridiculously long time, like millions and millions of years. This causes giant ice sheets and glaciers to spread all over the place, covering massive areas of the planet's surface. Believe it or not, our planet has experienced at least 5 major ice ages. The very first one happened about 2 billion years ago and lasted for 300 million years. The most recent ice age kicked off at around 2.6 million years ago, and we're technically still in it. So, we're in the middle of an ice age, but we're not currently living in an icy wonderland. That's because we're currently in an interglacial period. During an ice age, temperatures go through ups and downs. When it's warmer, those ice sheets and glaciers start to melt, creating what we call interglacials. And when it gets colder, they expand again, which we call glacials. So right now, we're enjoying the warm interglacial period of the most recent ice age, which kicked off around 11,000 years ago. When people mention the Ice Age, they're usually talking about the last glacial period that started around 115,000 years ago and ended roughly 11,000 years ago when our current interglacial period began. During that glacial period, things were way cooler than they are now. At its peak, when ice sheets covered most of North America, the average global temperature was about 46 degrees Fahrenheit. That's a whole 11 degrees Fahrenheit cooler than today's global average temperature. That temperature difference may not seem like much, but it was enough to turn most of North America and Eurasia into ice-covered landscapes. The Earth was also a lot drier, and sea levels were way lower because most of the water was trapped in those ice sheets. We're talking vast steppes, dry, grassy plains as far as the eye can see. And let's not forget about the savannas, warm, grassy plains, and deserts that were also part of the icy scene. During the Ice Age, there were some familiar critters roaming around, like brown bears, caribou, and wolves. But there were also some mega cool creatures that sadly went extinct when the Ice Age came to an end. We're talking mammoths, mastodons, saber-toothed cats, and giant ground sloths. Now, there are a bunch of theories floating around about why these magnificent beasts bit the dust. One idea is that us humans hunted them into extinction when we crossed paths with these megafauna. Our species, Homo sapiens, actually survived the Ice Age. We've been kicking it on this planet for around 300,000 years now, starting out in Africa and then spreading our awesomeness all over the globe. Some of our ancestors stayed put in Africa and didn't experience the full icy effects. Others ventured into different parts of the world, even braving the freezing cold of Europe's glacial environments. But we weren't the only ones out there. At the beginning of the Ice Age, there were other hominids, our closer relatives, scattered across Eurasia. We had the Neanderthals chilling in Europe, and the mysterious Denisovans hanging out in Asia. Sadly, both of these groups seems to have vanished before the Ice Age wrapped up. Now, there are countless theories about how our species managed to survive the Ice Age while our hominin buddies didn't make it. Some believe it's because we're ridiculously adaptable and used our social skills, communication, and nifty tools to our advantage. And get this, humans didn't just hunker down during the Ice Age. Nope, we explored new territories and made ourselves at home. For the longest time, folks thought humans didn't set foot in North America until after the ice sheets started melting. Fossilized footprints discovered at White Sands National Park in New Mexico prove that humans have been rocking it in North America for at least 23,000 years, right around the peak of the last ice age.
What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light-years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance. But even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system: Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago. But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that 2 gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other. And eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several hundred million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
Let's face it, as stars go, our sun is actually, well, pretty boring. Come on, there's nothing unusual about it. There are millions of similar yellow dwarfs in the universe. And yet, we love it. After all, it's the only star we have, and it gives us life. However, it wasn't always like that. Once upon a time, the sun had a twin, possibly an evil one. What happened to it? Well, let's find out. Now this here is a giant molecular cloud. They're also sometimes called dark nebula. Here, there are many interstellar clumps full of gas, dust, and piles of stars. These clouds have no clear boundaries and often take weird, crazy forms. You can even see some of them with the naked eye. Look at the clear sky at night. They look like dark spots all across the bright Milky Way. And this is exactly where our sun was born about 4.5 billion years ago. The sun originated from one of these molecular clouds. Billions of years ago, waves of energy were passing by here. They collected all this material and compressed these clumps into dense nuclei. That's when a protostar was born. This young protostar was a ball of lukewarm hydrogen and helium. And then, millions of years later, the temperature and pressure inside the balls increased. As a result, a star was born, the sun. But not everything in this molecular cloud has turned into the sun. The remaining materials began to revolve around the new star. And as you might have guessed, they gradually turned into planets, including our Earth. This is how our solar system was created. But it's quite possible that this is not the whole story, and that at the same time, along with our star, another one was born. The lost twin of the sun, made from the same materials under the same conditions. But why do we think that it exists? Well, recently, scientists have launched some statistical models to find out more about the birth of stars. And these models have shown that many stars appear not individually, but in clusters, or at least with one sibling. After more research, scientists confirmed that, yep, most stars formed inside molecular clouds are born with a companion. Sometimes these companions stay together. For example, a small star will revolve around a large one. They can even form double, triple, and other star systems. And sometimes their paths may diverge forever. This probably happened to our sun as well. It could have had a sibling too. Perhaps not even one, but a whole cluster of little brothers and sisters. And one bigger twin with a similar mass and other characteristics. But if that's the case, then where are you, our lost twin? Well, we have one hypothesis, and according to it, this twin may not be as good as it seems. In the 1980s, scientists began to notice a certain pattern in the Earth's history. Approximately every 27 million years, give or take, large-scale extinctions occurred on our planet. Pretty strange, right? Every 27 million years in the history of Earth, some kind of catastrophe occurred that changed its biosphere forever, as if something, as scheduled, cyclically, caused them. Then an astronomer, Richard Muller, suggested that there may be something that caused the events, a certain celestial body. According to him, it could be a dwarf star that we can't see because of how dim it is. It could be located about 1.5 light years away from us. This star rotates around the Sun in a huge orbit, and it approximately takes a whopping 27 million years for it to finish its orbit. And when it gets closest to the Sun, it starts to cause complete chaos. While approaching us, this troublemaker changes the trajectories of comets in the Oort cloud or the Kuiper belt. As a result, all these comets start to rush straight toward us. then they crash into the Earth and cause mass extinctions, just like it was with dinosaurs. This hypothetical star was named Nemesis. It's the name of the ancient Greek deity of retribution. What is it taking revenge on us for? No idea. Perhaps it didn't like the fact that once upon a time, the Sun took away almost all the dust and gas from a molecular cloud. The Sun became a fairly large star, but the twin remained dark and small. Moreover, in the end, it was forced to fly away in the middle of nowhere. Anyone would be annoyed by something like this. Scientists have put forward various hypotheses about what the mysterious nemesis is. Perhaps it's a brown or red dwarf, the remnants of a star that has completely depleted its fuel. Or maybe it's not a star at all, but a rogue planet more gigantic than Jupiter. Well, whatever it is, its existence isn't particularly pleasant for us. However, all our attempts to find the culprit unfortunately failed. At the moment, we still haven't found any signs of Nemesis. Recent studies have called into question the theory of regular mass extinctions. If you look more into fossil records, you'll notice that these catastrophes occurred rather randomly, rather than on a clear schedule. Now scientists doubt if Nemesis may actually exist. They also say that any star moving in a similar orbit would be very unstable, and it's very unlikely that it could have survived for that long. But despite the lack of clear evidence, Nemesis had become quite famous online. Many articles and news still mention it in different contexts. They like to write off any dramatic events taking place in the world, like asteroid falls, tsunamis, and so on this mysterious star. So now, all this may seem like a typical urban legend, but let's not forget about something important. Even if Nemesis itself doesn't exist, it doesn't mean that the Sun didn't have a twin. First of all, everything we talked about at the beginning is still relevant. Most stars aren't born alone. The probability that our Sun also had a sibling is still very high. Secondly, there may be evidence of the existence of this lost twin, and is probably somewhere in the Oort cloud. This is a huge cloud in the outer limits of our solar system. It consists of a bunch of comets and other cool rocks. Now, scientists believe that this cloud stores various remnants and fragments of everything that remained after the birth of our solar system. It's like a huge museum of our past. So, in this Oort cloud, scientists have noticed something interesting. Basically, this region seems to be too heavy. What the Oort cloud actually looks like doesn't correspond to our current models of the formation of the solar system. It's too heavy because there are some remnants of something in it. So, there used to be something in the solar system that we don't know about yet. But when scientists included a possible second sun in their calculations, it fit just right. Like a missing piece of a puzzle, the lost twin perfectly matches the gap in the weight of the Oort cloud. So yeah, the Sun almost certainly had a twin. But what happened to it? And where is it now? Unfortunately, this star is most likely already very far away. Probably after their birth, the Sun and daughter, Sun 2.0, spent only a couple of million years together, and then they had to separate completely. Now, the second twin may be hundreds of light years away from us. It can be anywhere in the Milky Way. And yeah, theoretically, we could find it, but that would be quite difficult. To do this, we need to find all the stars similar to our Sun, about the same age, all over the Milky Way galaxy. And even if we make a list of these stars, what's next? We have no way of knowing which one was really the twin of the Sun. So, the lost twin will most likely remain lost, and our Sun will remain forever lonely. Ah, what a sad story. But cheer up, for us it's probably the best. If we had two suns, perhaps the solar system would never have become what it is now. Our planet might not exist at all, and that means that there might be no life. So we probably should be grateful for the Sun's sacrifice. On the other hand, our sunsets would look like the ones they have on Tatooine. Cool. Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about 1/2 inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands, or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago. Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novopangea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novopangea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangaea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat. Wow, this port is so buzzing. Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, you're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool! Your couch is standing on the floor, your floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere. It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of two plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these two plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruptions slowly pushed the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the Sixth Ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that Sixth Ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid, and before the Red Sea actually starts flowing in there, many thousands, if not millions of years must pass. The continents move as fast as your nails grow, and imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the Afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts, and there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within, and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the Afar Triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to Southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow, just about 1.2 inches a month. Some of them move even 5 times faster though, but even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes, neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangea supercontinent. Even though it formed over 300 million years ago, and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangea. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole.
So many asteroids pass through our solar system and we don't even know about it. Those are rocky pieces of material left over from the time when our solar system was forming, about 4.6 billion years ago. They move around the sun, but not in the way planets do. We're talking about true rebels that prefer to follow some pretty strange paths. Plus, they spin in different ways as they travel between planets and other space objects. And the majority of them come from the main asteroid belt that's located between Jupiter and Mars. Most stay there. But Jupiter has quite a strong gravity, so it can push some of those flying rocks in different directions, and towards us too. They're sometimes round, and sometimes they have odd shapes, with pits and holes from all that crashing into other space rocks. As we currently know, there are more than 1 million of them in the main asteroid belt, and that's all good until some of them move in our direction. NASA keeps an eye on them, so we know everything's fine, at least for now. But that wasn't always the case with our beloved home planet. If Earth could talk, it would probably share so many crazy asteroid stories. We're talking about those space rocks that left impact craters we call domes. They have a specific shape with a raised center, similar to when you throw a pebble in a pond and see some water splashing upward. But we'll never be able to learn about many others. I know this raised center sounds like something you're supposed to see right away, especially if an asteroid that once slammed into the surface was big. But we're talking about millions and millions of years of erosion, so wind, water, and even gravity do what they do best and erase traces. They wear down impact domes, and some sites even end up hidden under layers of rock and dirt, or they disappear forever because Earth's tectonic plates keep moving around. Check out the Moon. It's experienced many collisions too, but over there, there's no ocean or tectonic plates moving around, or even wind to slowly, through millions of years, erase craters from its face. Basically, its entire history is written on its surface. But Earth has its own forces that can erase such places as the Vedafort impact structure and the Chicxulub crater. You know, the famous one that wiped out the dinosaurs? Luckily, scientists have new methods to find ancient craters. They often focus on the mess impacts made, which means the materials they threw around. And the Australian continent is especially interesting since we're talking about a playground for asteroid hits. By that, I mean ancient supercontinent Gondwana that dominated the South hundreds of millions of years ago. Experts know about 38 impacts, plus they speculate about 43 more. Some structures are relatively small, while others are big and completely hidden. And recently, a scientist named Tony Yates has discovered strange underground magnetic patterns in New South Wales, Australia. Yay! New clues of a giant asteroid impact! And when I say giant, I really mean it. It's a structure 323 miles in diameter. This might be the largest impact site ever found. This spot is called the deniliquin structure. Its magnetic patterns show characteristic ripples around the center, like when a rock hits the water. There are also fractures that go outward from the center. And it seems rocks from inside Earth ended up pushed into these fractures. That's a typical story for big asteroid impacts. This structure was probably located in eastern Gondwana hundreds of millions of years ago, way before it split into several continents, including Australia. At the moment, all we know about this crater is what we see on the surface. To find more information about this collision and get some proof, we'll have to drill into the ground. An asteroid this big is definitely not a joke. It could have caused a massive ice age and maybe even wiped out around 85% of species, even more than the asteroid that ended dinosaurs. In 4.5 billion years, which is how long our planet has existed, it's been punched by hundreds of big asteroids. But that doesn't mean every space rock that enters our atmosphere really makes it all the way to the ground. Most of those that manage to pass the atmosphere are relatively small, for instance, 3 feet across. That's good for us because any space rock that's less than 82 feet in diameter most likely won't make it past our planet's atmosphere. Since these space rocks come towards us very fast, they heat up the gases in the atmosphere, which burns them away. By the way, once cosmic intruders enter our atmosphere, they turn into meteors. And in most cases, they don't cause much damage, if any, as they fall down. But we used to have way larger things flying around and crashing into Earth. At least 190 of them have left scars you can still see today. One of the really big ones is in South Africa. It's 99 miles wide. It's actually the largest. At least that's what scientists think at the moment because they still need to check as many details as possible about this new crater in Australia. This one in South Africa formed about 2 billion years ago, and an asteroid that created it was probably larger than the one that had wiped dinosaurs away. And when an asteroid is bigger than 0.6 miles, it can have really big effects across the world. This impact was so strong that it could have caused fires everywhere and thrown lots of dust into the air. And when you have so much dust in the atmosphere, the climate on the planet can change for months or even years. Then we also have the most popular asteroid that made a giant hole we today call the Chicxulub crater. You know the story. It crashed into our planet 66 million years ago when dinosaurs were wandering around, catching food, falling in love. Basically, just doing their thing. The crash itself didn't erase them right away. It threw a lot of debris into space, and when it fell back to Earth, fires and flames were everywhere. The hit also produced a big cloud of dust that covered the planet for years. This cloud blocked the sunlight, which harmed plants and entire food chains. Even those dinosaurs that survived the crash and such difficult conditions had a hard time finding food, so they didn't make it. At least they left us many fossils and turned into the inspiration for movies and stories. A long time ago in Canada, something big crashed into our planet and left a big hole we today know as the Sudbury Basin. People used to think it was an asteroid, but now some experts think it might have been a giant comet made up of a mix of ice and rocks. The hole is almost gone now because of weather conditions though. But people still get to mine iron and nickel there, and at the same time find the leftovers of whatever space object fell there. If you move deep in southern India, you'll find a big hole called Lonar Crater. Locals stumbled upon it 200 years ago and believed it might be from a volcano. But now we know it's a trace from a meteor that crashed into the ground about 35 to 50,000 years ago. What's so special about this crater is that it's the only one known to have formed in a type of rock called basalt. Around the crater, there are hills covered in trees, and animals like peafowls and gazelles live there. Birds also like to visit the lake near the crater during the winter. And the lake itself is quite interesting too. It can turn pink because of all those tiny organisms that live there. But this color change doesn't last long.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangaea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangaea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangaea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research. But this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. and this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some Craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritius, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritius was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritius was covered in water when India broke away from Madagascar, something like 85 million years ago.
A mega drought might hit Australia soon, and this isn't just about a couple of dry seasons. We're talking about 20 years of little or no rain. While Australia could be facing the longest and most devastating drought since official records began, the rest of the world might struggle to buy bread, flour, or cereals. Energy prices are likely to spike globally, and neighboring countries like New Zealand, Indonesia, and Malaysia must be prepared to receive Australians directly affected by the lack of water. To truly understand how severe this situation could become, we should first examine past disasters. First off, Australia is no stranger to droughts, and this phenomenon can happen across their entire territory. From 2017 to 2019, the southeast part of the country went through what they call the tinderbox drought. This was a severe bone-dry event where the cooler months saw only about half the usual rainfall. Parts of Australia became so dry that wildfires were a constant threat. Crops failed, and water was scarce. This drought was also thought to have contributed to the Black Summer fire disaster. By the end of 2019, bushfires were raging across the country on a scale never seen before, with people describing them as rivers of lava flowing down from treetops. The losses were staggering. The The tourist industry alone took a hit of $2.8 billion, and over 7,000 jobs disappeared as a result of this difficult period. The tinderbox drought was a big reminder of what Australia might face in the future. That's why it's so important to understand what happened in the past to get a full picture of a possible 20-year mega-drought. But there is one problem. Even though droughts are relatively common in Australia, the rainfall data available until today isn't enough for researchers to predict the future, and our records only go back to around 1900. So experts decided to study tree rings to uncover missing environmental data. If you look at a tree stump, you'll notice concentric rings on its surface. As trees grow, they form new rings, and the thickness of these rings depends on how much water they get. During a mega-drought, the rings appear thinner because the trees don't have much water. Unfortunately, these natural records usually only go back a few hundred years, and it only tells us about specific local conditions, not the situation across all of Australia. So, experts turn to computer models to simulate how Earth's climate changed from the year 850 to 2000. This approach helped them to paint a picture of when mega-droughts might have occurred in Australia and how to predict what might happen in the future. But what they were really interested in was whether the human factor might be making this scenario worse over the years and if we are somehow intensifying these dry periods. So, are we to blame for these mega-droughts? The short answer is, we're not sure yet. On one hand, dry periods in Australia do seem to last longer than they did before factories and machines became common. On the other hand, they don't seem to be getting more intense or happening more often than before industrial times. This means a drought lasting 20 years might not be directly linked to human activities. Actually, this kind of phenomenon is just a normal part of how rainfall changes in Australia over time. This is backed up by evidence from ice cores, which suggests that a 39-year drought hit eastern Australia around 800 years ago. What makes it all so fascinating is that there isn't just one cause for this phenomenon. I mean, there is no single mechanism that explains all cases of megadroughts. It happens because the right combination of ocean and atmospheric conditions come together, and you end up with a drought. And just by random chance, you might have periods where there are 100-year-long droughts. Despite what many people think, megadroughts are not geographically isolated. They have occurred on every continent except Antarctica over the past 2,000 years, and are often linked to natural events. For instance, megadroughts in North America and Southwest South America were driven by El Niño, where the Pacific Ocean near the equator gets warmer than usual, disturbing normal weather patterns. They are not rare events either. In fact, the U.S. Southwest has been experiencing a mega-drought since 2000. It's being considered the driest period in 1,200 years for the region. Major reservoirs like Lake Mead and Lake Powell are at low levels. Heat waves are hitting cities like Phoenix and Las Vegas harder than ever, and wildfires are happening more frequently as the land gets drier. Now, let's think about the future. Even though we have a very recent and concrete example from the U.S., research can't exactly predict how a 20-year megadrought would play out in Australia. Usually, such events show up mainly as reduced rainfall and snowfall. But in most areas, the increase in drought risk will be caused by a warmer, more arid atmosphere. So the ground will probably look parched and cracked, rivers and lakes will likely shrink, and the sky will be relentlessly clear and blue, with barely a cloud in sight. Farmers might struggle to grow crops, making grocery prices rise worldwide. Things like bread, flour, and cereals may become scarcer, as Australia supplies about 13% of global wheat exports. Coal mines might be affected, as they depend on water for extraction, washing, and processing. That might drive up power costs for industries around the world, which could be passed on to consumers, impacting global growth and inflation. As cities might face water shortages, Australians will likely find new ways to conserve every drop or maybe move to New Zealand or Southeast Asia. Now, you're probably thinking, when is this big event going to happen? Honestly, it's really hard to predict exactly. Megadroughts can happen every 150 to 1,000 years, but experts think Australia should be ready for one to happen in the next 10 years or so. And this possibly should be taken seriously. This phenomenon has been known to contribute to the collapse of entire civilizations. Take the Akkadians of Mesopotamia, who built the world's first empire more than 4,000 years ago. Studies of moisture at the ruins of Akkadian cities suggest that they experienced a massive drought lasting 300 years, and this may have led to their collapse. A similar thing happened to the Assyrian Empire, which existed over 2,700 years ago, in what is now northern Iraq. For years, it was a real mystery why they left their capital of Nineveh and never returned. But recent studies of a stalagmite in the Kunaba cave revealed that the rise and fall of the empire coincided with a wet period followed by a 125-year-long mega-drought. Because they were very dependent on seasonal rain for agriculture, this dry period made their life much harder. Even though experts now believe they probably left because of the dryness, the question of where they went is still a mystery. So, yep, mega-droughts may have played a role in the collapse of great civilizations in the past. But on the positive side, we've come a long way since then, and recent climate technologies can help us prepare for events like this. Now that we know a 20-year mega-drought is very much possible and might happen soon, Australia has some time to get ready for it. Developing strong water management plans to mitigate the severe impacts of a mega-drought is more than necessary, and it's also important to create community support networks to provide emotional and financial support to people, particularly farmers, who are more affected directly by this event. If initiatives like these emerge in the coming years, those 20 years of drought could be less intense than most people might expect.
There's a stretch of water that even the most experienced explorers fear. No matter what season you choose to cross it in, you risk meeting face-to-face with waves that can reach as tall as the Hollywood sign. I'm talking about the Drake Passage, the waterway connecting the Pacific Ocean to the Atlantic Ocean, stretching from Cape Horn at South America's southernmost tip to Antarctica's South Shetland Islands. It's about as wide as the distance from London to Berlin and takes up to 48 hours to cross. Some sailors compare getting on the other side to going to the moon. That's how challenging it is. Even the man who discovered it, Sir Francis Drake, never sailed these waters because they seemed too dangerous to him and opted for a calmer, although longer, Strait of Magellan. The passage took the lives of around 20,000 sailors and over 800 ships. Tourists who want to see Antarctica cross the Drake Passage on a regular basis, although it's still often called the world's most terrifying ocean crossing. The Antarctic Peninsula, where travelers go, isn't really part of Antarctica itself. It sticks out and points towards South America like two fingers almost touching it. The water gets squeezed between these two land masses, making strong ocean currents. The passage is part of the Antarctic Circumpolar Current, the largest ocean current on Earth. The water rushes through the passage at a speed between 95 and 150 million cubic meters per second, which makes it rougher. And then there are winds that usually blow from west to east and are very strong between 40 and 60 degrees latitude. That's why those areas are called the Roaring Forties, Furious 50s, and Screaming 60s. Land slows down winds, which is why storms hitting Ireland and the UK get weaker as they move east. But Drake's latitude is the only place where winds can blow all around the Earth without being stopped by land, so they keep getting faster. These strong winds turn into huge waves that can hit ships really hard, normally around 13 to 16 feet tall. They're much higher than waves in the Atlantic. Drake Passage also has underwater mountains that you can't see. The huge current squeezes through this narrow passage and causes waves to crash against these mountains underwater. These internal waves create whirls that bring cold water up from the deep ocean. So it's not just rough on the surface, the water is wild all the way down. The first sailor managed to sail around Cape Horn and through the Drake Passage in 1616. It was a Dutch navigator, Willem Schouten, in 1616. But the most famous attempt to cross it was undertaken by Sir Ernest Henry Shackleton on his ship named Endurance. He and 27 of his men set off from South Georgia, aiming to reach Vassal Bay in Antarctica. But things didn't go as planned. On January 19, 1915, their ship got stuck in the ice. And by October, it began to sink. They camped on floating ice for 2 months before sailing lifeboats to a remote, icy place called Elephant Island. Shackleton and 5 men made a risky journey to South Georgia to get help. It took them 15 days to cross Drake Passage with hurricane winds. Finally, they arrived safely and organized a rescue for the rest of their crew. Scientists found the shipwreck of Endurance only in 2022, 10,000 feet below the water. In December of 2019, 6 fearless athletes decided to cross the Drake Passage by rowing a boat for the first time in history. It took them 12 days of non-stop rowing with a 90-minute rotation of rowers. They managed to do it, and it was probably the hardest possible way to cross the passage. The athletes mentioned it was cold, wet, and dirty, and the waves hit them like walls. The weather in the Drake Passage changes a lot, but ship captains can always see it coming and change their path. They will move the departure time to have a safety margin and not to get stuck in the middle of the passage in the worst possible conditions. Sometimes, the journey will be smooth and calm, and they call it Drake Lake. Other times, people on the ship will feel rough waves, which is called Drake Shake. Some experienced captains who often cross the passage say that the Drake Lake effect happens once in every 10 crossings, and they see the Drake Shake once or twice in every 10 journeys. A schooner or a kayak will probably not survive the journey among giant waves, but modest vessels and cruise ships have sturdy hulls and advanced stabilizing mechanisms. So, the journey isn't that dangerous anymore, but still, it's quite an adventure, especially if you're seasick. If you don't feel like risking it but want to travel from the Pacific Ocean to the Atlantic Ocean by water the fast way, the Panama Canal is waiting for you. People first started thinking about making a water path across Panama in the 16th century. Back then, a Spanish explorer found out that only a thin piece of land separated the two oceans. But it seemed impossible to build it because of the mountains and thick jungle, so the idea had to wait a couple of centuries. Finally, in 1880, France, led by the man who built the Suez Canal in Egypt, tried to make the canal. But the people who started the construction soon found out it was much harder than it looked on a map. The land in Panama was one of the toughest and most dangerous places to dig a big waterway. Workers had to literally move huge mountains in a jungle full of snakes, where it was really hot and rainy. During the wet season, heavy rain turned rivers into wild rapids and soaked the workers. Sometimes, they didn't see the sun for 2 weeks, and their clothes stayed wet all the time. Big rocks were falling, and tiny mosquitoes that carried malaria made people very sick. And then, an earthquake happened on top of everything. They were losing thousands of people. That's why France decided to abandon the project after 7 years. Then, the United States bought the French assets in the canal zone and finished it by 1914. It cost the US around $375 million. The 50-mile-long passage of water saves ships traveling between New York and San Francisco 7,872 miles. Around 14,000 ships use it every year and pay around $1.8 million in tolls. So it looks like it all paid off. Another challenging waterway in this part of the world is the Amazon River. It's around 4,300 miles long and flows through 3 countries with over 30 million people living in its basin. But there isn't a single bridge across it. The river has many marshes and soft soils, so engineers would need to build very long bridges and very deep foundations, which costs a lot of money. Building bridges over deep water is tough, but in other places in the world, engineers can use things like floating platforms to help. The river's path and water levels change a lot during the year. During the dry season from June to November, the river is usually 2 to 6 miles wide. But in the wet season, from December to April, the river can become as wide as 30 miles. And the water level can rise by 50 feet. That's why they can't build floating bridges or pontoons. The riverbanks are made of soft dirt that moves and erodes with the seasons, and it makes things even harder. It would have to be an absolutely unique project to overcome all these challenges. Luckily, there's no pressing need for a bridge across the Amazon right now. The river mostly goes through areas that are sparsely populated, so there aren't so many major roads to be connected by bridges. Around 5.3 million years ago, a crucial event reshaped the Mediterranean region. It was a colossal flood that refilled the local sea, which had been extremely barren and salty up until that point. It got the name Zealandia Flood, and it forever changed the geography of the area. The Mediterranean Sea is surrounded by Europe, Africa, and Asia, and connects to the ocean by the Strait of Gibraltar. This is quite a narrow passage, measuring about 8 miles. It may not be that wide, but the strait plays a crucial role in maintaining the liquid balance between these two bodies of water. About 6 million years ago, a bunch of things might have caused the Mediterranean to be cut off from the Atlantic Ocean. Some say it was an ice age. Others speak of tectonic movements, like earthquakes. Whatever the cause, it pushed the Mediterranean area into a period called the Mycenaean salinity crisis. For about 1,000 years, the sea slowly evaporated, leaving behind a dry basin that was several miles below sea level. This crisis really changed the landscape, creating conditions similar to those found in today's Dead Sea. What this means is that the lush Mediterranean beauty used to be a super salty environment, containing nearly 10 times more salt than the ocean. Say you could have visited. You would have been able to effortlessly float on the little water you could find, even if you're not a skilled swimmer. The amount of salt and that mineral content would have made it challenging for most creatures to survive. However, some hardy microorganisms, such as bacteria, could have adapted to these harsh conditions. These days, at the bottom of the Mediterranean Sea, we can find holes as large as the Grand Canyon, and they seem to have formed during that same period of dehydration. Evidence suggests that massive rivers, such as the Nile and the Rhone, flowed directly into the Mediterranean back then, leaving behind canyons as they reached the bottom, thousands of feet below the sea level. People had to find some sort of explanation back in the day for the drying of the Mediterranean, so they came up with myths and legends. One such tale was told by the people of southern Iberia, in modern-day Spain and Portugal. It was also recounted by a famous Roman writer called Pliny the Elder. What this legend said was that the Mediterranean used to be cut out from the ocean until the hero Hercules, with his mighty sword, carved a path. He did so between a fictional location in modern-day Africa and the Rock of Gibraltar. This allowed the ocean waters to flow in, transforming the Mediterranean into what we know today. Some fossils also seem to confirm the unusually large flood. Remains of marine organisms were found in layers high above current sea levels. This means the areas were once submerged underwater. These fossils belong to mollusks, fish, and marine mammals. Because of modern techniques, we now have at least an estimated timing of the Zealandia flood. Scientists used computer simulations to reconstruct the event, providing further evidence that it was real. What they also discovered is that there's a possibility the Mediterranean might change once more. The Strait of Gibraltar could close, most likely because of movements deep under the ground. This could lead to the Mediterranean becoming dry again, over a span of about 1,000 years. The Mediterranean area could disappear altogether if the African continent keeps shifting north too, getting closer to Europe. Another one of those famous yet still a bit hypothetical large floods is called the Black Sea Deluge theory. Some scientists think that around 8,400 years ago, water from the Mediterranean might have spilled over into the Black Sea through a narrow passage called the Bosporus Strait. This could have caused a massive disaster, forcing people living near the Black Sea to pack up their things and move further inside the continent, in both Europe and Asia. Along with them, they might have carried stories about this colossal flood. The specialist that came up with this idea also suggested that these migrating people might have brought along new ways of farming. Not everyone from the scientific community is convinced, though. Some argue that while there might have been a flood, it likely happened earlier and was way smaller. They didn't think this flood could have caused, for example, the story of Noah's Ark. In this legend, a spiritual man was warned by a higher entity that a giant flood was on its way. The man went to gather pairs of animals and pack them all in a boat to make sure these species would survive the devastating flood. There was also the concern among scholars that discussing real floods and ancient stories too much might blur the lines between science and fiction. There may be other reasons why these flood stories are so often found across different cultures all over our planet. One idea is that floods were incredibly destructive for early farmers, so they invented myths about them signaling the end of the world. Another idea is that people stumbled upon ancient sea creature fossils in unusual places, leading them to believe there was a significant flood in the past. The solution to future floods, though, might be floating cities. As sea levels continue to rise, coastal cities like Amsterdam, New Orleans, and Venice may go under. So, floating infrastructure may be the way to go, with buildings that can rise with the water levels, making them able to resist extreme weather too. Countries like the Netherlands, which have a history of managing water risks, are pioneering these floating creations. With cities running out of space for expansion, we might be forced to move on water anyway. By moving on the water, we can reduce crowding and create more interesting ways to feed ourselves, like floating gardens. These homes also come with great alternatives to our energy needs through systems that use solar and wind power. Not to mention that these homes might turn out to be cheaper in the long run. One such floating city might pop up soon in the Maldives. Its goal is to host up to 20,000 people and will feature places to live and eat, but also shops and schools. Designed to look like coral, the region will include canals placed between some 5,000 floating pieces of land. The city will be constructed using modular units, put together in a construction site nearby. After they're completed, they'll be towed to the floating city. The next step is to secure them to a large underwater concrete hull, which is screwed tightly to the seabed on some steel stilts. All these pieces of construction let the modular units easily move as naturally as the sea. Even for those that are afraid of seasickness, there's a solution. That's what the nearby coral reef is for. It will surround the city, making a natural wave breaker. Human-made coral banks will also be placed underneath the city, which will also help coral grow naturally. The long-term goal is to make the establishment self-sufficient. It will have electricity, mostly from on-site solar power. Waste will be treated nearby and reused as plant fertilizer. Instead of air conditioning, the city will use deep-sea water cooling. This method pumps cold water from the deep sea to cool the area, saving energy. Earth is not the only planet that's seen some serious floods. In ancient times, Mars seems to have experienced them too, and they played an important role in shaping its surface. Recent research reveals that billions of years ago, Mars was heavily affected by some serious river flooding, which contributed to the formation of its valleys and canyons. The reason for these floods was heavy rainfall, which reshaped the Martian landscape in a jiffy, at times even within days or weeks. Unlike Earth, where rivers form pretty slowly, Mars experienced rapid changes because of these floods, particularly around 4 billion years ago. We've known for quite some time that there have been floods on Mars, but this study really showed us their extent. We now know they were more widespread and frequent than previously thought. Why is Australia so strangely empty? Why haven't we discovered so much of the ocean? Is our planet a perfect sphere? And was the Earth once more purple than green? I bet you didn't know these facts about our planet, so let's find it all out. Australia is really massive. To make it easy to understand its size, it's nearly as large as the entirety of Europe. Home to around 26 million people, Australia is among the countries with the least population per area. It's ranked only 55th for the highest population in the world, while it has the 6th largest land area. Why is so much of it empty? A good guess would be the many dangerous animals hiding behind every rock. At least this is enough for me to avoid Australia. But there's one specific reason to explain this. The dryness of Australia ensures that 85% of the population lives within 30 miles of the coast, and 80% of them live along the eastern side where rainfall is more common. But although there is an overall lack of rainfall, only 20% of Australia is unlivable desert, and only 40% is considered not habitable by human standards. The water consumption is actually higher than their average rainfall each year, but there is a further ancient water source hidden way below, which can support a much larger population. It's one of the largest underground freshwater resources in the world, the Great Artesian Basin. It covers a staggering 656,000 square miles, which is 1/5 the size of Australia. It holds enough water to cover the Earth under a 1.5 feet deep layer of water. Or, more usefully, it could provide enough water for thirsty Australians over the next 1,500 years. Only 6.5% of Australia has soil suitable for farming, so this doesn't seem like a huge amount. But in case you forgot, Australia is big, and this small percentage is about the size of France. With this massive area available for farming, Australia has more than enough to feed its population, with a further 70% of agriculture products that are exported overseas. So, with plenty of land, food, and water, why are the population figures so low? A very slow migration process is the reason. First, only people from the United Kingdom lived there. Then, they opened their borders to other Europeans, and this restriction remained in place until 1973. You would think almost 200 years would be enough time for a lot of people to migrate, but Australia was just so far away. The risk of traveling such a long way and the cost of the journey meant that people from Europe prefer the shorter and cheaper options to migrate elsewhere, like Canada or the USA. For the past 2,000 years, people have understood that Earth is round. But did you know that it's not a perfect sphere? Through the wobbly rotation of Earth, our planet constantly changes its size, very slowly of course. The North and South poles are surprisingly flat. Earth is pretty much like a ball being squished. Imagine there's a giant hand with the fingers pressing at both poles. Because of this pressure, the equator pushes a little outwards. Along with an uneven gravitational field, Earth has loads of gravity glitches, some positive and others negative, creating an uneven, rocky, and bumpy surface. Some places on Earth have more gravity than others. If you weighed yourself along the equator, you would weigh 0.5% less than at the poles. Not a whole lot, and definitely not worth the trip to change your weight. If you were to measure the length from the center of the Earth towards the furthest point of Earth, you would be shocked that Mount Everest isn't at the end of it. Instead, it's along the equator, which is the pushed-out part. Ecuador's mountain Chimborazo would actually be the tallest point on Earth, as it's the furthest from the center. We still have around 80% of the ocean to map, which is crazy considering how much of the solar system we've explored in comparison. But we're still aware of many of the unbelievable details about the ocean. It covers over 80% of the world's surface, where 94% of the Earth's wildlife lives. And from some of the life in it, up to 80% of the world's oxygen is produced mainly from plankton, algae, and bacteria. One of the most famous already mapped places is the Mariana Trench. It's the deepest point on Earth, as low as almost 7 miles deep. That's a huge 5 times the length of the Grand Canyon and deeper than Mount Everest is tall. It's also home to one of the most ancient seabeds on Earth, casually laying low for about 180 million years. The pressure at the bottom is over 1,000 bars, but although this is 1,000 times more than normal pressure, life still flourishes here. Throughout the ocean, there is an estimated over 3 million shipwrecks lying in the murky depths. Countless artifacts sit there untouched, and there could be more than all the world's museums. The mid-ocean ridge is the longest in the world, reaching 40,000 miles. That's almost 10 times the size of the Andes, the longest mountain range on land. The sun is the reason behind the blue and aqua colors of the ocean. This color isn't from the reflection of the sky, though they are both blue for the same reason. The surface of our planet receives white light from the sun, and it absorbs the orange, red, and yellow light stronger. It doesn't absorb the blue light so much, so it returns to how we see it. Of course, this only occurs based on how pure the water is. If the water is full of mud or algae, they scatter the light and overpower the water's natural blueness. There are many factors that determine what color we see on our planet. Could you believe that the Earth was green before? Instead, it was purple. Chlorophyll in our atmosphere absorbs mainly blue and red wavelengths from the sun and reflects the green ones to what we see our planet as today. Long ago, ancient microbes called retinol dominated the Earth instead of chlorophyll. They absorbed green light and reflected red and violet light. Those microbes had a simpler structure, so they were easier to produce in the low oxygen environment of the early Earth. They provided our planet with a purplish color instead of green. But chlorophyll is more efficient, and as the Earth was developing, it eventually took over. Imagine that billions of years ago, faraway observers could see our home as a small purple dot. I wonder if we could have also been purple. Probably not. The biggest tree on Earth is a giant sequoia named General Sherman. It stands over 280 feet, almost reaching the height of a 26-story building. They believe it to be 2,700 years old, with a circumference of 1,000 inches. Its weight is a staggering 1,800 tons. That's heavy, but it isn't the heaviest living thing on Earth. In Utah, a huge grove of trees called Pando works like a single colony of trees. The massive root system connects all of them together with up to 47,000 stems. It weighs up to 6,000 tons and is 80,000 years old. It makes it the oldest living thing known to humans. Now, what about the biggest area of one being? Off the coast of Western Australia, a seaweed grows to an unthinkable size. The Poseidon's ribbon weed has been growing for 4,500 years, spreading underground clone shoots. It's all connected and shares the same DNA with most of its shoots. It covers a massive 77 square miles, the same size as 28,000 soccer fields, or the size of Nebraska. And it won't stop there either, as it continues to grow by 2 feet each year. It's hard to even picture the scale of these enormous beings. Now, just imagine if they were all purple.